Hello, everyone, and welcome to another episode of Clay Loves Logic, where on this channel I solve logic-based Sudokus I find interesting. Today, I'm going to be looking at the puzzle Sniper in the Mist by Flinty. And as always, I'll put the link to this puzzle in the description so you can try it out if you'd like. But with that in mind, let's get to the rules. Normal Sudoku rules apply. You have to have the digits 1 to 9 in each box, in each row, and in each column. Fog of War. Most of the grid is covered in fog. Excuse me. As you solve, more of the grid will appear. So what that means is if we knew what this digit was, say this digit was a 4, all of these would light up if we put a 4 in and we were correct. Killer cages. Digits in the cage must sum to the number in the top left corner, and digits cannot repeat within a cage. So this, actually here, this one we can see all of, because we know the cage goes into here. We know it's only 3 cells. So these 3 cells have to sum to 23. And then we know that because it says all cages are exactly 3 cells in size and do not overlap or share cells. I'm reading the rules before I started the video. So if this is 23 in 3, it's always 6, 8, 9. That's the only way you can make 23, because the maximum you can make is 7, 8, 9, and that's 24. And if it's only one smaller, we can only just change the 7 for a 6. There's not another way we could do it. Which means this and this are 6, 8, 9. Because again, look, we know that the cells or the cages are 3 long, and we can see this sort of dotted line. We know that has to extend to here. And then if we look at this 23 cage, it starts here. We know it has to extend at least here. And it doesn't go into this one. And then the same can be said about this 7. This is a 1, 2, 4 cage, because that's the only way you can make 7 in 3. But what that means is this 23 cage goes here, because where else can it go? The cages don't overlap. It tells us that. They don't share cells. Can't go here or here. It has to go here. And that's going to mean these 2 digits are the same because they exist in the same cage, or they exist in, you know what I'm trying to say. Sorry, big yawn. It's been a long day. These are the same. They just have to be. Okay. 24 cage can only be 7. All colors. 24 cage can only be 7, 8, or 9. Now, I don't know if it goes here or here, but that's what we know. There's a lot of ways you can make a 20 cage. So I don't know what's particularly interesting about that yet. Maybe let's turn our attention to this 21. How do you make 21 in Sudoku? Well, you could do, what if you maximize? What if you always have a 9? Then you could have 9, 8, and 4, right? 9 and 8 is 17 plus 4 is 21. So you could have 9, 8, and 4. You could have 9, 7, and 5. Yeah. Okay. What if you don't ever have a 9? You could have 8, 7, 6. Yeah. And that's the smallest combination of digits. So, and I'm going to claim that we can't have this as 6, 7, 8 because we already have a 6 and an 8 in this row, and we already have a 6 and an 8 in this row, which means we'd have to have one of those digits here. So this can't be 6, 7, 8. And in fact, neither of these could be 6 or 8. So how do you make it? 9, 7, and 5 is what we said, right? 9, yeah, because 7 and 5 is 12 plus 9 is 21. And that's going to give us a digit because there's already a 9 here. There's already a 9 here. Where do you put a 9? It's here, which means this is from 7 and 5. And that is our first digit of the puzzle. Very fun start. And now we have another 21 cage. And it could use a 9. And the 9 would be here. And I think, in fact, 6, 7, 8. No, well, let's just think now. How could this be 6, 7, 8? This would have to be a digit that's not a 6 or an 8 or a 7. This is never 6, 7, 8. So there's always a 9 in this cage. And if there's always a 9 in this cage, it means it's here. And then this is not 9 anymore. Oh, that's fun. Okay. So now there's a 9 up here. And actually, that's interesting. There's a 9 up here. We need to have a 9 in the 24 cage. This is a 9. Ah, and look. The 24 cage goes down into this cell. This is a 5, 7. So this is an 8. This is a 7. Great, great puzzle. Wow, awesome. So this has to be a 6, 7, 8, doesn't it? Doesn't it? It just does. And this is not a 7. So then what are these? What are these digits? This can't be a 6, an 8, a 9, a 5, or a 7. This is a 4 then, right? Because that's the only other combination we said we had. You could have 9 plus 4 plus 8, right? Let me check my math. 9 plus 8 is 17 plus 4 is 21. Yeah, so this has to be a 4. This is an 8. This is a 6. That's going to clear some more fog. And we are absolutely moving and grooving with this puzzle. This is a great, great start to this puzzle. Wow. Okay, so what about this 20? I don't know where this 20 cage goes, but I know it at least goes here. So we have at least 2 digits of the 20 cage exist here. There's a world where it could go down here, but no, actually it couldn't. This has to be 2 digits of the 20, and we have to maximize them. This has to be 5 and 6. 5 and 6 give us 11. We need a 9 to make 20, and it can't be here. This is a 9. Haha, nice. Okay, this is not a 9 anymore. Oh, this puzzle is just brilliant. So fun. Okay. I'm going to pencil mark these 1, 2, 3s in. Not necessary, not interesting yet, but that's what they are, so might as well put them there. A 19 cage that doesn't use a 9, a 5, or a 6, does that mean it has to use an 8? If we have an 8, we have to have 2 more digits sum to 11. And without using a 9, it could only be 7 or 4. So I think that's just what it is, right? 8, 7, 4. 7 and 4 is 11. Yeah, it is. It is. And so this is a 4, and that's going to clear some fog. And then I don't know what's 7 and what's 8, but they're there. And what that means is neither of these are 8, which means this is an 8, which means this is an 8. And then we know we have an 8 somewhere down here, which is fine. Oh, and that did a whole bunch of stuff. Look at that. Okay, a 20 cage has popped up. Let's focus on the big numbers. A 20 cage has popped up, and what we know about 20 cages is, do we need a 9? Did we establish if we need a 9? It actually doesn't matter. It doesn't matter, does it? Because we can't have a 9 in this 20 cage. Look, this is a 6-9 pair, so there's no world where you put a 9 in here and then there's a 9 here. So even if the cage, and in fact the cage does have to go here, because how does this 12 cage get out? This is a complete 12 cage that goes like that. And so the 20 cage goes here. So we have to do 20 in 3 digits that don't use a 9, which is fine. But if they have a large digit that's, well, the largest digit we could have in this box is a 7. Because 6, 8, and 9 are spoken for. So if you have 7, you could have 8, and that could be outside of the box, and you could have 5 in the middle. And in fact, is that the only way to do it? 7, then you need 14. Right? Is that what I said? 7 and 8 is 15 plus 5 is 20. 7 and 8 is 15 plus 5 is 20. If you have to have a 7 in here, 7, 8, I don't think you can do it with 6. Well, we can't have a 6 in here anyways. This would have to be a 6. This would have to be 7. 7 plus 6 is 13 plus 7. Doesn't work. So in fact, we have to have a 7 and a 5 over here, and then this is an 8. Yeah. And this is a 7-5 pair, which means this 12 cage is all of a sudden starting to be pretty interesting. Oh, that's going to resolve this too, which will give us a few more things. Maybe. Gives us a cage, but we don't know what digit it is. That's fine. Okay. Very interesting. Great start to this puzzle. Let's look at this 12 cage now. The 12 cage all of a sudden is pretty interesting because these composition of digits, right? If we look at what we have, the 6, 9 are spoken for, the 5, 7 is spoken. These digits are just from 1, 2, 3, and 4, and this one's not from 4 because of this 4. So at most, these 2 digits are 4 and 3. And 4 and 3 would give us 7. This would be 5. If this was 4 and 2, this would have to be 6. If this was 4 and 1, this would have to be 7, and it can't be 7. Okay. If this was the next, well, and actually the next biggest combination doesn't work because 3 and 2 gives us 5, and that requires a 7. And 3 and 1 gives us 4 and would require an 8, which we can't have. So this is a 5-6 pair out of nowhere. And then these digits are from a whole bunch of things. I mean, there's a 7 somewhere, but like, I guess there's a 7 here or here, whatever. It's not interesting. There's a 9 up here. Again, not really interesting yet. Oh, look at that. There's a 5-7 pair here. That gives us a 6, which is going to give us a 5, which is going to give us a 6. And it's going to help us figure out these now have to sum to 6. They can't be 3 and 3, so they can only be 4 and 2. So this is a 4 and this is a 2. This is a 1, and that's going to clear a little bit of fog. And now we know that this is a 2 and this is a 4 because these 3 digits have to sum to 7. And the 1 saw a 4, and yeah, that's all there is to it. Okay, now this is a 3 by Sudoku. It can't be anything else. 3 in the corner. Lovely. Which means this is now a 3, doesn't it? Because where do you put a 3 in this box? Well, you can't put it up here. You can't put it here. This is a 3, which means there's a 3 somewhere down here. I have to let my dog out. Sorry, pause the video really quick. Okay, I'm back. I will have to get up again to let my dog back inside in a minute, but for now, let's resume the puzzle. This is now a triple, isn't it? This is 3, 5, and 2 in any sort of combination we'd like. This is only from 1 and 7. This is only from 8 and, or sorry, this is only from 9 and 4 in no combination. These 2 digits are now only going to be 1 and 2. Okay, so now we have to think about a 21 cage in 3, and we have to ask ourselves, is it ever 2 or 3? The answer is no, right? If it's 2, it has to sum to 19, which we can't do. If it's 3, it has to sum to 18. We also can't sum to 18. It's just not possible. They have to be double 9s. This is a 5. That's going to make these 9 and 6. Usually, or 9 and... Wow. Okay. Just total lapse in my brain there for a minute. 21 minus 5 is 16. So to get to 16, we need a 9 and a 7. Yeah, that's going to do it. That's going to give us a 1 and a 7. A 7 in the 10 cage, when our only other options are 2 or 3, means this has to be a 2, and this has to be a 1. So that's going to give us a 3 there. A 7, 9 is not going to do anything for us just yet. 7, 9, 7, 9. Yeah, that's not going to do anything for us just yet. 15 cage. Maybe that's interesting, but it might not be yet. I'm not sure. Probably it is, right? I mean, what could this digit be? 6, 7, 8, and 9. The biggest this could be is, and it can't be 1 or 2. That's actually a little bit interesting. This can only be 3, 4, or 5. So there's some restriction happening there. If this was 5, we need 2 digits that sum to... Oh, I don't think this can be 5. Look, if this is 5, you need 2 digits that are going to sum to 10. And it can't be 1, 9, can't be 2, 8, can't be 3, 7, can't be 4, 6. Because these 2 digits see all of those. So this could never be a 5, actually. So now it's interesting. If this is a 4, these 2 digits sum to 11. And they can't be 2, 9. They can't be 4, 7. They could only be 3, 8. No, they could be 5, 6. They could be 5, 6. Okay. little bit more options. And then if this is 3, these sum to 12. And if they sum to 12, not going to be 9, 3, not going to be 4, 8, not going to be 5, 7. So in fact, this is a 4. Yeah, because there's just no other option. So then this is now all of a sudden a bit of a, quadruple. This isn't 3, and one of these is 5. And can this ever be a 1? You'd have to have 2 digits sum to, oh, that's actually how we're going to solve this, is this 9, 7, 8, right? Because if this is a 1, these 2 digits sum to 17, and the only way to do that's 9 and 7, and this has the exact ability to be neither of them. So this can't be a 1. I feel like 2 is going to be just as restrictive, right? This is 2. You have to make 2 digits sum to 15. And you can do it, but it's either 6. Well, yeah, it's precisely just 6 and 9. Okay, so that tells us there's always look, a 7-9 pair. I'm not getting ahead of myself here. 4-9. Just saw that. Okay. Sorry, what was I saying? Right, if this is a 2, these two sum to 15 and they're 9 and 6, which just barely works. If it's a 5, they have to sum to 12. And if they sum to 12, how do they sum to 12? If that's a 5, they sum to 12. And they're not going to be 9 and 3. I guess if this is 2, if this is 5, they need to sum to 12. They could be 9 and 3 if this was a 3. If this was a 5, these sum to 12. Could they be 8 and 4 ever? No. This couldn't be neither 8 nor 4. And then 7, 5 is the only other option. And it would only ever work if this was a 5 and this was a 7. Oh, but that doesn't work. Yeah, that doesn't work because there's already a 5 here. This cell's always a 9. Okay, interesting enough. So now, yeah, that still all makes sense. This is going to be from what? 1, 2, 3, 5, and 7. There's always going to be a 2. Oh, actually, there's not a 2 here. Because of this 2. This is only from 1 and 3. And actually, that means this is only from 1 and 3 because we have a 5, 7 pair. Okay. There's 6, 8, 9 triple, which means one of these is a 4. 1, 2, 1, 3 pair. Actually, what else do we need here? We have 6, 9. It's like, oh, neither of these are 3. Oh, this is 3. Yeah. Because of this 3. Which means we need a 1 somewhere over here. So what is this now? This is going to be just a pair of 1, 2, 3, just 4 and 5. Doesn't resolve yet. But now we know we have a 3 over here. 1, 2, there's a 3 somewhere over here. 4, 5. This is just the remaining. Okay. Where should we turn our attention to next? This 16 cage, perhaps? Well, maybe, maybe we think about. That's what I want to think about. Where does a 5 go in this box? There's a 5, 7 pair here. So 5 can't go along the bottom. There's a 5 here. This is a 5. And that means this option, what did we say? It has to sum to 10. No, it has to sum to 11. So this is now no longer 5 or 6. All of a sudden, this is 3, 8. And we have a naked single here. And it is going to be 1, 2, 3, 4, 5. This is going to be a 6. Okay. So now what? There's a whole bunch of stuff we can do. This is now a 1 because, right, look. Oh, my dog's barking. 1 second. Pause the video. Okay, where was I? What do we need here? These 2 digits. What are they? They're only going to be from 2 and 5, right? Yeah, so this is a naked single, and it is a 6. Okay, so now what are these 3? This is a triple. From 1, 2, and 3. This isn't a 2. And that's all we can say. So neither of these are 1 anymore. So that's interesting. Where does a 1 go here? Just in one of 2 spots? Fine. What about these 2 digits? 1, we need a 2 somewhere here. And we need a 3, and I don't know who's who yet. But that's fine. What about this? We're going to need a 2, 3, and a 4. And this isn't a 3. Okay, 1, 2, 3, 4, 5, 6. This could just be about anything other than a 5. Big whoop. Let's think about a 16 cage that actually 16 cage is interesting now. Now that this is a 1, 2, 3 triple, and this is just a 3 now. Yeah. So this is a 2. So this is a 1. So this is a 5. And this is a 2. And we'll think about that cage in a minute, but now we're on a run. This is a 4. And this is a 5. And yeah, wow, all of a sudden, this is now something 3 plus, 8 or 6 or 9 or whatever. I don't know. Doesn't matter. Let's think about this again, because I want to ask the question, a 16 cage that can't have low digits is all of a sudden pretty restricted. What's the biggest digit this could be? If it's 7, then the remaining digits have to sum to 9, and they'd have to be 4, 5, 7. And is that the only way to do it now? And I want to claim that it is. And I want to claim it is because of the following. If it's not 4, 5, 7, then it has a 6. And if it has a 6, it needs 2 digits that sum to 10. And the only available option would be 4 and 6. We'd have a repeat 6. We cannot do that. So these all of a sudden are now just from 8, and that's going to give us a digit. Actually, that's going to give us a 7. Because we know there's an 8 here now. So this is 7, 8. This is no longer 7. These 2 digits are going to be 8 plus 6, and that's going to resolve because of this 6. So we're going to get an 8. We're going to get a 6. We're going to get 2 9s. We're going to get a 6. We're going to get an 8, and we're going to get a 6. That's going to give us a 7, which is going to give us a 9, which is going to give us a 5, which is going to give us a 4, which is going to give us a 7, which is going to give us a 3, which is going to give us an 8, a 3, a 7, a 5, a 7, a 5, a 7, 4, anything, I guess. 1, 2, 3, or 6. I guess I have to do math in this 17 cage. The 17 cage has a 9 in it. The remaining digits have to sum to 8. So no, that still works anyway. 5, 3 is fine. 6, 2 is fine. Okay, so what's next? Is there any other math to be done? And I want to claim that there's not. Oh, there's always a 1 in this row, which means this is a 2, which means this is a 1. The 2 means there's always a 2 over here. So this is a 3, this is a 2, this is a 3, this is a 6, this is a 2, this is it's not this is a 1, this is a 5, this is a 1, this is a 2. Yes, congrats, you solved the puzzle. The solution is correct. 25 minutes 36 seconds. 2,395 people have solved this puzzle in 288 days. I did like this puzzle. It was fun. Okay, good. Everyone, thanks for watching. I hope you enjoyed, and we'll catch you on the next one. Thanks.